Today we're going to bring back a problem we looked at earlier in the year called the difference quotient. You'll remember I showed you this picture where we took a graph and 2 points on it and created a secant line, a line that intersects the graph in 2 points. And then we talked about the fact that if I could move this point close enough to the other point, I would have a line that was appearing to be tangent to the graph. And we talked about the fact that the distance between these points on the x-axis was h. And if we could get h to be as small as possible, whisper small, dust mote small, we could actually envision a line tangent to the graph. And the difference quotient, that f of x plus h minus f of x over h, generated the slope of this tangent line. Okay, so now we're ready for today's lesson. So the tangent line problem. We're actually going to do the difference quotient, then take the limit as h goes to 0. We're actually going to make the distance between these 2 points nothing. And then what we will get is a formula for the slope of the tangent line. And the slope of the tangent line in calculus is called the derivative. It allows you to derive the slope of a line tangent to a graph at any point. Okay, so let's start with f of x is equal to x squared minus 3. Use the limit process to find the slope of the tangent line to the graph of the function at the specified point. Okay, let's remind ourselves what x squared minus 3 looks like. Right, it looks like a parabola. Move down 3. So we could imagine that the tangent line at 0, -3 would actually be 0, a little horizontal line. The tangent line anywhere along this side of the parabola is probably a negative, having a negative slope. And the tangent line anywhere along this side more likely has a positive slope. And we're looking for the slope at the point 1, -2. So we're envisioning that the tangent line would look sort of like that. And the limit process should give us a formula for slope that would generate a positive number. Okay, so let's actually go through that. Remember, f of x plus h minus f of x all over h, and then we're going to take the limit as h goes to 0. That's our process. So in the numerator, we have f of x plus h minus f of x. So f of x plus h would be x plus h squared minus 3, and f of x would just be x squared minus 3. So we get x squared plus 2xh plus h squared minus 3 minus x squared plus 3 all over h. My x squareds will cancel, my 3's will cancel. The remaining terms, oops, that's from a different thing. Sorry about that. The remaining terms each have a factor of h, so we're going to get 2x plus h times h, and that's going to cancel with this h. Okay, now we're going to do the limit as h goes to 0. And so if h goes to 0, we get 2x. So our slope formula is 2x. So let's use that. So the slope is going to be 2x, which is going to be 2 times 1, which would be 2. So the slope of this line is 2. Just to show, let's pick point negative 2, right? Negative 2 would be at 1, negative 2, 1. Okay, so then the slope, negative 2, 1, we're predicting the slope would be some negative number. So the slope would be 2 times, the slope would equal 2 times negative 2, which would be negative 4. So we'd have a negative slope of negative 4 for the tangent line over here. Let's try it again. G of x is the square root of x plus 10. Remind ourselves what that looks like. So at negative 10, right, and it goes kind of like this. And we're looking for the slope at negative 1, 3. So I'm anticipating the tangent line looks sort of like this. So I'm expecting a pretty shallow but positive slope. Okay, well, let's run the formula. So this would be g of x plus h, which would be x plus h plus 10 minus g of x, square root of x plus 10, all over h. If I tried to take the limit as h goes to 0, I would zero out both the numerator and the denominator. So I'm going to need one of my tricks. Let's rationalize the numerator by multiplying it by square root of x plus h plus 10 plus the square root of x plus 10. We'll do that on the bottom. Square root of x plus h plus 10 plus the square root of x plus 10. So my numerator, first terms, I'm just going to get x plus h plus 10. Outside terms and inside terms will cancel out, so then I'm just going to get minus x plus 10 over h. That minus sign will distribute. Then my x's will cancel, and my 10s will cancel. So I'm just going to get, oops, I forgot my denominator. Square root of x plus h plus 10 plus the square root of x plus 10. There we go. Okay, and so my numerator has an h in it. That h is going to cancel with the denominator h. And I'm going to get 1 over the square root of x plus h plus 10 plus the square root of x plus 10. And we're going to take the limit as h goes to 0. So as h goes to 0, the denominator is square root of x plus 10 plus the square root of x plus 10. So 1 over 2 square root of x plus 10. So that's my formula for slope at any point along the graph. So we're looking at the point negative 1, 3. So the slope is going to be 1 over 2 negative 1 plus 10. So 1 over 2 times the square root of 9, 2 times 3, 6. So the slope at the point negative 1, 3, oops, negative 1, 3 is 1/6. So a positive slope, but shallow. Find a formula for slope at any point on the graph. Use the formula to find the slope at each point. Okay. These are different directions, but they're asking us to do the exact same thing. Find that slope formula. So we're going to use the limit as h goes to 0 of the difference quotient. Okay. So I have x plus h cubed minus x cubed over h, which is x cubed plus 3x squared h plus 3xh squared plus h cubed minus the x cubed over h. My x cubes are going to cancel. Every remaining term has an h in it, so I'm going to factor out that h and cancel it with the denominator. 3x squared plus 3xh plus h squared, and I am going to take the limit as h goes to 0. So this term will zero out, and this term will zero out. And so my formula for slope is 3x squared. Okay, well this graph, we know x cubed. Looks like this. So at 1, 1, if you envision the tangent line, we're expecting a positive slope. 3 times 1 squared, 3. And at negative 2, negative 8, we are also expecting a positive slope, but perhaps a steeper positive slope. 3 times negative 2. 3 times negative 2 squared. Negative 2 squared is 4 times 3 is 12, so the slope is 12. Indeed, it is a positive slope. Find the derivative of the function. Okay, these are the exact same directions, only in the most compact calculus form. It could also have asked us to find what's called y prime. That's a name for the derivative. F prime of x, that's the derivative. Dy over dx, that's the derivative. Dx of y, that's also the derivative. So the derivative goes by lots of notational names, depending on what kind of application you're doing. So find the derivative. So we're going to do the exact same thing that we have been doing. F of x plus h minus f of x all over h, and then we'll take the limit as h goes to 0. So negative 5 x plus h plus 2, negative 5 plus 5x, pardon me, plus 2. So we've got negative 5x minus 5h plus 2 plus 5x minus 2 all over h. The 5x's cancel, the 2's cancel. We've got negative 5h over h, which is just negative 5. The limit as h goes to 0, there is no h, this is a constant, so it is negative 5. So the derivative is negative 5. In other words, the formula for slope. Well, this was a line, so its slope is the same everywhere. So that should make sense that for a line, the slope is the same everywhere. Okay, one more. X plus h squared minus 3x plus h minus x squared minus 3x all over h. X squared plus 2xh plus h squared minus 3x minus 3h minus x squared plus 3x all over h. The x squares cancel, the 3x's cancel, every term has an h, so 2x plus h minus 3. We're going to take the limit as h goes to 0, so we're going to get 2x minus 3. So this is our derivative. It is our formula for the slope of the tangent line at any point along the graph.